Hi, we had a calculus test last week over limits and continuity, and so I'm going to go over this test during this video lesson. Using the graph of f of x, answer questions number 1 through 6, 1 point each. Here we have the graph of f of x, and the first question is find the limit as x approaches negative 2 of f of x, and so we have negative 2 here on the x-axis, and from each side the limit appears to be converging on x equals 0, so that is our answer for number 1. Number 2, the limit as x approaches 0 of f of x. So here we have x approaching 0, and that also happens to be on the origin, so the answer appears to be 0. And problem number 3, the limit as x approaches 2 of f of x. Well, here's 2, and we have from the left side approaching 4, and from the right side we have approaching approximately 3. So these limits do not match up across the fence, and so that limit does not exist for x equals 2. Now we have the limit as x approaches negative 1 of f of x. So now we go to negative 1 right here, and we notice from each side the limit appears to be converging. If that's 2, this should be 1. F of 0, well, what is f of 0? If we put 0 as an input here, we come right to the origin. So f of 0 appears to be 0. And finally, f of 2. So we go look at input 2 to this function here, and we go up, and there's a hole here at an output of 3. But at 4, that appears to be f of 2. So these will be question numbers 1 through 6 answered. Next, using the graphs of g of x and h of x below, answer questions number 7 and 8 below. Okay, note each grid square is 1 unit square. And so here we have, for problem 7, the limit as x approaches 0. This little negative sign in the exponent position is 0 from the left side of h of x, of g of x. And so here's g, and we go to 0 from the left side. Here we are approaching 0, and it appears that this limit, if 1 unit square counts for 1 point, that's going to be negative 2, so negative 2 comes in this place, plus limit as x approaches 1 from the plus side of h of x. So we go over here to h, and we go to limit as x approaches 1, and here's 1. And so from the right side, that looks like 1, 2, 3. So 3, we have negative 2 plus 3, which equals 1. So that will be number 8 answered. For number 7 answered. Number 8, we have limit as x approaches 0 from the plus side. And so that's a g of x. So here we approach 0 from the plus side. It looks like we come down to 2. And then over here on h of x, as x approaches negative 2, from the plus side, well, here's the plus side going to negative 2, and that value looks to be 1. So 2 plus 1 equals 3. So there we have problem 7 and 8 answered. Next, we have a series of problems here for 9 through 16 based on this graph here, p of x. And so the limit as x approaches negative 2 of p of x. And so we go to -2, come up here, and it looks like from each side we're converging to the same value, so that appears to be 3. Problem 10, the limit as x approaches 1 from the negative side of p of x. So here's 1, okay, and we go from the negative side, from the left side, and it looks like that limit is converging to an output of 1. And it doesn't quite touch because of that hole, but the limit is what the function converges to, not what the function is defined at x equals 1. So then we have the limit as x approaches 1 from the positive side of p of x. And so from the positive side, we're coming here. As we go to 1, it looks like our output value is going to be -1. And then we have the logical follow-up question, 12, what is the limit at x equals 1? We see here that these limits from each side do not match up. So this limit over here, as x approaches 1 of p of x, DNE, an acronym for does not exist. Next, problem 13, we have the limit as x approaches 4 from the positive side. So here we approach from the positive side, and it looks like as we go from the positive side, the value of the function is going up toward infinity. Actually, that was from the left side. This is 13 as x approaches 4 from the left side. That's this side. And now as x approaches 4 from the positive side, well, that's going to be problem 14. Likewise, infinity. So, and another thing, that a limit where there is infinity, in fact, that limit does not exist. Well, in this case, the limit as x approaches 4, which takes into account both sides together, they approach infinity, both of them, and therefore limit does not exist. To have the limit to exist, both sides need to approach a real number. 16, the limit as x approaches infinity of p of x. And so this would be the definition of a horizontal asymptote. And we can see it appears as we go farther and farther toward infinity, the function appears to be settling down to, but not touching the x-axis. So we'll say the answer to that is 0. So those will be problems 9 through 16, the first page of our test. Next, we have problems 17 and 18, which are evaluating tables. Sometimes they can be a little tricky. And you look and try to answer the questions about which approaching from each side. And so for this limit, as x approaches 2 of f of x to exist, the limit as x approaches 2 from the left side of f of x needs to equal the limit as x approaches 2 from the right side of f of x. And so from the left side, here we have x, we're going close to 2, 1.9, 1.99, 1.99, and so on. We're getting closer and closer, and it appears the value appears to be approaching 16. This thing is getting closer and closer to 16. And from the right side, we're going down very slowly to 16. So it appears that these are both approaching 16 from each side, which means the limit exists, and the value of that limit will be 16. It appears to be anyway, in spite of f of 2 being undefined. So that's probably a point discontinuity. And 18, we have the limit as t approaches 0 of g of t. Well, here, from the left side, again, same definition, except I'm going to put approach 0 from the left side, 0 from the right side. And here, we're going down from 2.1 and so on to, looks like we're going close to 1 as a limit, 1.0, and from the right, we're also going down very gradually to 1.0, even though we at f of g of 0 is going to be 15. So the limit from the left side equals the limit from the right side, apparently. So we say that the limit as t approaches 0 of g of t is 1. So now we're going to go to the next phase. This will be problem 19. The limit as x approaches 3 of this function equals, and what we're going to do is quickly evaluate what this function value is. So I'm going to work over to the left and save this for my answer up here. And so here, find the limit. We say if as x approaches 3, we have 3 minus 3 in the denominator. Numerator, we have 3 squared minus 2 times 3 minus 3, and this is going to be 9 minus 6 minus 3, so we have 0 over 0. And I like to tell my students, anytime you have indeterminate 0 over 0, we have more work. Okay, so we're going to do that work and see if we can factor the numerator, and the denominator comes down as x minus 3. And if we can factor out, we know that one of the factors of that numerator is likewise going to have to be x minus 3. And so now we can figure out, what do we multiply by x to get x squared? Well, x. What do we multiply by negative 3 to get negative 3? We get positive 1. So now we can cancel these out, this removable discontinuity, and plug in 3. So our answer is going to be 3 plus 1, which will be 4. That'll be the limit, even though at this discontinuity, because there is discontinuity, the function value does not exist at that point. Next, 24, limit as x approaches 8 of x over x minus 8. We can try to plug in 8 for x here over 8 minus 8. So we have 8 over 0, and that is going to be undefined, or you could say, or does not exist. Put DNE for does not exist. And there isn't any additional factoring we can do here to fix that problem. And next we go to problem 20. Limit as x approaches 7 of 3x. Well, this is going to be quite simple. There's no great simplifying to be done, so we have 3 times 7 is 21. So that would be our answer for problem number 20. For problem 25, we have the limit as x approaches negative 5 of x plus 5 over x. So let's just substitute in. We have negative 5 for x in the numerator plus 5 over negative 5 in the denominator. So negative 5 plus 5 equals 0 over negative 5. And so we have a numerator of 0. That is going to simplify to 0. So those will be our answers for these 4 problems. Let's go on to the next set of problems. We have problem 21. The limit as x approaches negative 2 of 3x plus 6 over x plus 2. So first we're going to plug in for x. So the numerator, we have 3 times negative 2 plus 6 over negative 2 plus 2. And simplifying this out, we get negative 6 plus 6 is 0, and negative 2 plus 2 is also 0. And so we're going to look to try to simplify this. and factor further. Again, more work, okay? X plus 2 is what we have in the denominator, and we can factor out 3 from each of these terms in the numerator, so we have 3 times quantity x plus 2. We have a cancellation, so we have 3. And we notice that we don't have left to plug anything in for this one, so our answer is 3. Next, problem number 22. Okay, as we plug in 9, we have 9 minus 9 over here over 81 minus 81, and this simplifies to 0 over 0. Again, more work. And let's see, let's go ahead and work that out. We have in the denominator y minus 9, and down here we have quantity y minus 9. If we're lucky at all, we'll be able to factor that out. We're using the difference of squares. We'll have y minus 9 times quantity y plus 9. And so if we cancel these terms out, the y minus 9 and y minus 9 cancel equal 1, we have 1 plus y, 1 over y plus 9, which when we substitute in 9, we get 1 over 9 plus 9, which equals 1/18. So our answer for this one, our limit is y approaches 9 of this function here is going to be 1/18. Next, this one over here, we have limit as x approaches infinity of this expression here, divided by another. If we have the powers of the exponent equal, the highest powers, which in this case we have to the third power, we'll use the ratio of the coefficients. So we have, because relative to the highest power, these other ones here of lower power are really of no consequence. So what we do is we say that our answer is going to be the coefficient on the top divided by the coefficient on the bottom. So we have -5/2 for our answer for 26. For 27, the limit as x approaches infinity of this numerator divided by this denominator. Again, we look for the highest power in each of the numerator, both the numerator and the denominator. In this case, we have x to the 4th, and we have x to the 3rd power. Now, one thing that did trick my students taking the test was this 6th right here. No, this is not something to the 6th power. This is not x to the 6th power. This is 10 to the 6th power. This is 1,000,000 x cubed. And so our answer to this is going to be simply, we have a bigger on top situation. As we go toward infinity, what looks like that's going to be, we're going to go to negative infinity because we have a negative coefficient top, but in either case, the function, the limit as x approaches infinity is not going to exist. So that's our answer to 27. Let's go on to the next couple here. Okay, 23. We have the limit as x approaches -2 of x plus 6 over x plus 2, and so we plug in -2 plus 6 over -2 plus 2, which equals -2 plus 6, that's going to be +4 over 0, and it looks like we could try to factor, but we're not going to be able to factor anything out here. So our answer is going to be undefined. You put infinity, does not exist, undefined. You get across the same thing. On the right here, 28, when I did this first, I did a lot more work than I had to. First thing we do is try to plug in -2 to the numerator and denominator. Well, if we plug in negative 2 in the numerator, we get negative 2 cubed minus 8, and in the denominator we get negative 2 minus 2. Well, negative 2 squared is going to be negative 8 minus 8, and then we have negative 2 minus 2, so we have negative 2 minus 2. So our simplification is going to be negative 16 over negative 4, which with a negative divided by negative cancel equal 1, so we're going to be left with 4. So our limit as x approaches negative 2 will be 4. Okay, next. Okay, we're given a 5-point problem here involving a piecewise function. We have let g of x equal this piecewise function, 2x plus 7, when x is less than negative 1, and negative x plus 4 when x is greater than negative 1. And so the limit as x approaches negative 1 from the left side of g of x, well, from the left side is going to involve this piece here. So we put 2 times negative 1 plus 7, which equals negative 2 plus 7. So from the left side, our answer is going to be 5. All right? Part B, the limit as x approaches negative 1 from the positive side of g of x. So that is going to be this bottom piece here, because x is greater than negative 1. That's from the positive side. So we just put negative 1. I put the negative 1 in parentheses here. That sometimes avoids mistakes. So we have negative 1, which is going to be 1 plus 4 is going to be equal to 5. So again, from the right side, we're equal to 5. And now the limit as x approaches negative 1 of g of x, which means the left side and the right side, if they match up, we're going to successfully have a limit here. And that, since the left side and the right side match up, that value of the limit is 5. Next, g of negative 1. Well, one thing you may have noticed is we have this piece here for x is less than negative 1, this piece here for x is greater than negative 1, but we do not see another piece that takes care of the function when the value of the function when x equals 1. So in this case, g of negative 1 is not defined, does not exist according to the pieces we have available. And lastly, E, is g of x continuous at x equals negative 1? Why or why not? Continuous, no, it's not. And a reason, you can give different reasons. The reason I like is g of negative 1 does not exist. Okay, so that's going to be problem number 29, 5 points possible. Next, we get to problem number 30, which has 3 points possible, and determine if the following function is continuous for all real numbers, justify your answer. And so, for the first thing we have to look at is, one, ask the question, does g of it says for the point where we're going to have the problem is this critical value here of negative 2. So otherwise this function is going to be continuous because each of these pieces is a polynomial function. So g of negative 2, if it exists, well, the answer is yes, because this piece here is for less than or equal to negative 2. Yes. And next we're going to find out what g of negative 2 equals. G of negative 2 is going to be equal to 3 times negative 2 squared plus 4. And so we have 3 negative 2 squared times 3, that's going to be 12. So 12 plus 4 equals 16. All right? And this is also going to happen to be, we're looking for the limit now. Okay, the limit as x approaches -2 of g of x is equal, and the limit as x approaches -2 from the left side of g of x has to be equal to the limit as x approaches -2 from the right side of g of x. And I'm going to put above that a question mark because we don't know if these limits from each side are equal to each other. And so the limit as x approaches -2 from the left side, well, we've already figured that out when we evaluated f of -2 because we took the value of the left side here. So from the left side, the value is going to be 16. And the right side now is what is in question, which is going to be -2 times -2 cubed minus 1. Well, here we have, we're going to bring down 16. Well, -2 times -8 minus 1. And so we have, in this case, that's going to be 16 minus 1. So that's going to equal 15 on this side, on the right side. And we know that 15 does not equal 16. So this limit here of g of x as x approaches -2 does not exist. And so this is the reason, not continuous, because limit as x approaches -2 of g of x does not exist. Okay, 3 points possible. Next, problem 31. Find the value, parentheses, values of k that will make the following function continuous. So let's go ahead and look at that. For that, we're going to use the same principle we used in problem number 30, and we're going to take, in this case, x, we'll say limit from the left side. So limit as x approaches, in this case our critical value here is 3. 3 from the left side, or from the left side, that's this lower one of f of x, equals the limit as x approaches 3 from the right side of f of x. And so now we're going to find out what those limits are. And now we're going to substitute in from the left side piece. So we have on the left side 3 times 3 is what we're looking at, plus 1. That's the left side, equals, now we take the right side, which is 3k squared. So k, we don't know what that is going to be our unknown, minus 2. So now we can set these, we can simplify. So we have on the left side 3 times 3 plus 1, which is 10, equals 3k squared minus 2. Next, we're just solving for k. We have plus 2 on each side. So we have 3k squared equals 12. And solving for k, dividing by 3, we have k squared is equal to 4. And taking the square root of both sides, we have k is equal to plus or minus 2. Now, some of my students did this fine, except we didn't get plus or minus 2, but value. So there are 2 correct answers. So you got point taken off if you didn't come up with the 2 correct values, but otherwise your work was fine. A lot of people just came up with 2. Next, problem 32. Complete the following statement. Use math notation. 1 point. The limit as x approaches a of h of x exists if and only if, and we've been using this notation pervasively throughout this test, and that is only if the limit as x approaches a from the left side of h of x is equal to the limit as x approaches a from the right side of h of x. There we go. That is your answer to problem number 32. And now we get to problem number 33. Find the intersection of the lines x equals 2 and y equals 5. And so if we have a vertical line, x equals 2, intersecting a horizontal line of y equals 5, we are simply going to have the coordinate pair 2, 5. And so that is our correct answer for problem number 33. Lastly, problem number 34. We have find the integral from 0 to 4 of 3 dx. And this gets back to an exercise we had earlier. What we're conceptually looking at is if we have the function y equals 3, okay, so there's y equals 3, this horizontal line, and we're evaluating this function, the integral from 0 to 2, 3, 4, we have essentially above the x relative to the x-axis, we have a rectangle that measures 4 long by 3 high, so our answer here is 12. So that's the entirety of the test. I hope you were successful at it, and I hope that this will help you in your preparations as we go to our next phase of calculus. Thanks.